Hello and welcome to this new video. It's a pleasure for me to see you here and what we are talking about today. So today we are talking about security along the whole DevOps pipeline. And if you're interested in this, then stay tuned. By the way, my name is Sven Robert. I'm developer advocate for JFrog, and I'm here right now in the Swedish woods. So if you are the first time on my channel, then a big welcome from my side. And if you like this video, give me a thumbs up and subscribe my channel, please. It would be really a big pleasure for me to see you as my new subscriber. So, okay, enough. Let's start with the topic. Okay, so why should I think about security along the whole DevOps pipeline? Well, right now we are in the middle of 2022. We have different situations or things are changing, and it means that even if you're working inside a small and medium business size company, the attacks and cybersecurity risks are increasing day by day. So what supply chain security mean is normally that you are looking at a process from the first beginning of the idea until there is something that's delivered and running in production, and everything that's coming from outside, everything that is delivered, every interim step, every result or whatever. So it's a whole process with all processes, humans, products that are involved, services and so on, that they are part of the supply chain security, and you try to harm the whole chain. And then it means that you are part of the supply chain from a bigger picture. So if you are delivering through a big company something that they are using and so on. So you are part of their supply chain, and so you're part of their supply chain security. But the topic itself is a very broad one, so we have to narrow it down to supply chain security for software development. Okay, supply chain security is a big topic for sure, and if you're looking just at the supply chain for software development, then we have one typical chain that is that you can follow. It's from source code. Okay, source code can be compromised with dirty commits and all this stuff, or with merge requests. Then you're pushing the source code to a source code repository. This repository itself can be compromised or attacked from the source code repository. The source code is then delivered to the CI environment, so even this communication between these elements can be bypassed, or inside the CI environment. The CI environment, the build service can be compromised. A very prominent example is, for example, the SolarWinds hack, or the not only the build configuration but the whole system, or the dependency that the system is collecting to or fetching to build stuff that can be with malicious packages or vulnerable software components. And then if you have this binary, it's pushed to a repository before it's delivered, and even here you have this communication challenge so that you can bypass stuff, and then the repository itself must be hardened, and so on and so on. So you see that we have along these stages a lot of this infrastructure things, so how these infrastructure things are making sure that they are getting and requesting what's allowed, and so on and so on. But what does it mean for a regular software developer in his DevOps environment, his DevOps lifecycle? This is a different thing. By the way, if you want to know more about the supply chain security for software or software supply chain security, then have a look at this open source project called Salsa. It's an open source project under the from the Linux Foundation, and the project Persia, that's an open source project. It's donated to the Linux Foundation right now and will be part of the Linux Foundation soonish. So we are now in July 2022, so maybe in the future it's done this process. And so have a look there if you have this generic software supply chain security approach. But now what is the difference now for the DevOps cycle? Because this is exactly what the developer has to do in his daily life. Okay, looking at examples from the software development world, let's say you are a developer and you know there was a SolarWinds hack. So what happened here? The very short version here is that this company is building software and CI environment, or they have a CI environment, and the main thing is that they are building this stuff and then automatically pushing these updates to all the customers. So this hacker group broke into their network, targeted the CI environment, and changed the build process itself in a way that with every commit or with every build, the binary was built and then additional malicious code or compromised code was added to this binary, and then the result of this build was a compromised version of the original program. And at this point it was just delivered to all the customers. So what can you do as a software developer? So at what stage you can make sure that this is not affecting your work? This is one example, but I have another one as well. Okay, another example I want to mention is the Log4j shell hack thing. Yeah? So it's a very typical thing because a software developer that is dealing with dependencies and bring in a widely used dependency, at what stage it should be possible to detect there is a vulnerability, or there is a configuration issue, or there is malicious activity and all this stuff, so that you can prepare, because we need some information about at what stage we can identify this, at what stage we can make sure that we are getting rid as fast as possible, what are the feedback loops, what tools in each of these DevOps cycle steps can be used to make sure that we are not going in this trap again and again. So this is a very basic example inside the typical developer world, and now it's time to see, okay, in all these DevOps cycles or DevOps steps, what exactly is the right security mechanism to make sure that I'm doing the best at this place? Okay, one of the first things is the planning phase. The planning phase in the DevOps cycle. So here, what you should be, or what should you do, is security by concept. Security by concept means that you have an eye on how this process can be misused, who's communicating with whom. So what information is really necessary to do this job? Can you reduce the amount of needed information? What is the trade-off between convenience and security on the concept or during the concept phase? I see so often that this concept phase is just not done in terms of looking from the security angle on this challenge, because then you have a conceptual challenge that you try to harden later on in this process or with technical things, and this makes no sense. So make sure that concept or security by concept is one of the main things in the beginning if you are thinking about the process, what you want to synthesize, what you want to create, what you want to write, who is communicating with whom, and all this stuff. Because the concept itself is one of the really strong things to harden the whole thing. Okay, and one thing that is what you should do is that you are thinking about the concept of zero trust environment. Zero trust environment means that every component that is communicating between each other, or all elements in an infrastructure, environment, whatever, is not trusting other components. And if you're doing this inside your infrastructure, why not doing it with your microservices as well? So if you're deploying infrastructure and you have different microservices, don't trust other microservices. Make sure that they are communicating in an encrypted way. Make sure that they have a key database where they can share communication keys and all this stuff. So make sure that the zero trust environment is part of your delivery of a bunch of microservices, and this is one of the core concepts. Don't do it just in the infrastructure, do it inside your microservices as well. Okay, if you want to start in this conceptual phase, or you want to have some guidelines for this conceptual phase, then I can recommend this project Salsa, SLSA, and it's Salsa.io, I think, the web UI, and it's part of the Linux Foundation. So search for Salsa and Linux Foundation, and then you will find this documentation project. And this documentation project itself has two main areas. One area is the description of this typical development production line. And inside this production line, what are prominent attacks, what they have done, how to harden it, so that you're understanding a little bit more the mechanics for the infrastructural part. And on the other side, you will find these levels, and this means that there is a description so that you can identify, okay, on what level I am, what is missed for the next, or what's missing for the next level. And then you can use this one to increase step by step your security along this infrastructural part. And yeah, so it's an open source project. So if you want to be involved in this, feel free. It's just in alpha phase, or it's right now in alpha phase, but it's growing and very active. So it's really worth having a look there and check it out. So, by the way, if you want to have a way more detailed description of this project Salta, what are the steps, what are the levels and all this stuff, then check out my YouTube channel. I have there videos that's explicitly just over this project Salta and explaining all the different steps and parts and what's going on and the current state and so on and so on. So yeah, feel free to have a look at my YouTube channel and search for Project Salsa at this point. Okay, the next phase is a coding phase. And the coding phase, what can we do during the coding phase? And the first thing what I want to highlight here is secure coding practices. Secure coding practices means that you are focusing on best practices for all these different elements like data input, data output, file handling, session management, authorization, and so on, error logging, and all this stuff. So there is documentation available from OWASP team. I think something, maybe I'm writing it down here in the description, and they will see the secure coding practices. It's a big document with all these different steps, and then you have really practical steps. Okay, if you're loading data, then make sure that you're not doing this and that. If you have session handling in your web app, make sure that the login process is not bound to a session, and then if it's necessary to create a session, close it, and so on and so on. So you have a bunch of this really straightforward advice, it's really recommended, so that before you're thinking about all this external stuff, that you're just making sure that the solid base, or that you're building a solid base with your own code, if you're following the secure coding practices. And then you can start step by step, first inputs and outputs and error handling and so on and so on. Okay, if I'm now able to code with all the security guidelines or with secure coding practices, the next thing is how to deal with dependencies. And here I want to highlight that an efficient dependency management will make sure that you are minimizing efforts or challenges if there is something that you have to clean up. So for example, you have this Artifactory where all these dependencies per technology layer coming through, so you're independent from the outside. If it is available, yes, no, you have the central place where you can scan. You have this possibility to analyze what dependencies are used in all these different projects. And here, what should you do as a practical advice if you're a software developer? If I'm in a project, make sure that you are not using the same dependency in different versions. Make sure that you're not using overlapping dependencies like Jakarta Commons Lang and Google Guava and whatever that have more or less the same functionality, so that you are deciding, okay, which one is the one we want to use, so that the knowledge about how to use it efficient, what are the best practices, what was going good, what was going wrong, and all this stuff, that this is inside the team, very broad, this knowledge. And then if you have to change dependencies, that's very easy to change the source code, because everywhere you're using the same version of this dedicated dependency. So it makes sense to have a very efficient and straightforward dependency management, just to make sure that you don't have this really far spread versions and dependencies all over the place, because this makes things just complicated. Okay, so if I'm managing dependencies, the next step is scanning dependencies. So I'm grabbing dependencies, I have transitive dependencies, and then I'm scanning the whole tree that is coming with this dependency I'm using. And it makes sense to have this during the coding phase directly inside your IDE. So if you're thinking, okay, that's my use case, this I'm writing by myself, for this I'm using a dependency, then I'm adding a dependency, and immediately I need all the information about vulnerabilities, malicious code packages, obfuscated code inside this stuff, and so on. So all the security information straight inside my IDE. So shift left inside the IDE makes sense, because then I'm losing way less time compared to I'm doing my stuff and then maybe the CI environment is complaining later. So make sure that this information is available. So if you have this Artifactory in X-Ray scanning the stuff in Artifactory, then it can connect with the IDE plugin through this X-Ray instance. And adding a dependency means scanning the whole dependency tree, getting the vulnerability information straight in your IDE, and then you can change and tweak it before you're even writing one line of code. Yeah, so if I'm managing and scanning dependencies, what the next was helping me during the coding phase, strong test coverage. So if I have a strong test coverage, then I can implement a very efficient dependency management, because I can change dependencies and I see immediately what's going wrong on it. And if I get the information about vulnerabilities, I can immediately change the versions in a way I have less vulnerabilities. Let's say test run, and if everything's green, I can deploy. So strong test coverage, so TDD during the coding phase, is a very, very strong thing. And I can really recommend using something stronger than pure line coverage, so something like mutation test coverage, because with this you have a way or a tool that will help you to bind the test coverage very, very strongly and tightly to the actual ongoing or the code you are writing. So have a look at mutation testing. I have something on my YouTube channel about it, and then you will see that with a very efficient dependency management and vulnerability scanning in combination with strong test coverage, it's the way to go. Okay, now I'm writing code and then I want to push it to some code, to some CI environment. No, it's good advice that if you're doing all this stuff, that a second person will have a look on your source code, or every code will be reviewed by something. So it could be in pair programming, it could be in a way of a classical code review, but it's always a good advice that someone else is looking at this code to see, is this code fulfilling the secure coding practices? Is the code coverage good enough? It's really strong code coverage. Is the code easy written and extendable, so that someone will see immediately what this code should do? And is this code definitely just doing what it should do, and not some special features are added with some funny whatever things, okay? So it makes sense that someone else will check the source code, and it could be removed, it could be in the same room, it could be whatever, but someone else will have time to check exactly this code to make sure that this code is following the guidelines. There's one thing I want to mention here is I see so often that people are using secrets inside their code, API keys, passwords, whatever. So a lot of stuff. Don't do it. Just don't do it. So even in binaries, you are able to find the secrets very easily, because there are tools available that are explicit searching for this, and it makes sense so that you are not adding secrets inside your code. And I don't know how often this must be mentioned, but it's still done so often. So really, don't use secrets in code. That's the only thing I can say. But yeah, and check your own code base if this is done, and then try to remove it immediately. Okay, so after coding, what's the next phase? It's building, and building means you need build server. And here the prominent example of what can go wrong is the SolarWinds hack, where this build infrastructure was just compromised. But on the other side, if you're using a Jenkins or whatever, Have you ever checked this Docker image you're using against vulnerabilities? Have you ever scanned it and removed vulnerabilities and maintained this piece of infrastructure like it's done with production code? Mostly I'm getting the answer, no, we're just using the official Docker image. So make sure that you harden this build environment, and then there is a big question: who can do it, what you should do, where's the right place to host it, and so on and so on. Maybe external companies or security audits will make sense, and so on. So just an example, I checked 3 or 4 years after I left one company. I checked if I can log into this build infrastructure, because this was public available, because the developer wanted to work from home, sure. And after this long time, I was able to log in with an anonymous user, so not a user that was bound to my identity. And then I could create new users, change build plans, saw what's going on. A disaster, a full disaster. So make sure that the build infrastructure is maintained like an operative system. So make sure that users are deactivated. Make sure that the user management system is combined with the actual managed user infrastructure you have. So if someone is leaving, that this account is deactivated and all this stuff. So harden your build infrastructure. Okay, and if you're working on open source projects, or you want to harden open source projects, then you can have a look at the project Persia. Persia.io is a project that was originally started by JFrog, and then the source code was donated to the Linux Foundation, and maybe soonish it's a Linux Foundation project itself. So what's Persia? Persia is a distributed dependency management system with a build layer. And just in a few words, so you have source code and you're pushing the URL where the source code is and the commit to this node. Then inside this peer-to-peer network, they will decide what node should build all this stuff. And then you have different nodes that are building it at the same time. And then they're comparing the results. So what you make sure with this approach is that you are not making sure that the code is not compromised, but the build is not compromised. So the build infrastructure is not compromised. Then if all the binaries are the same, then they're pushing this one to the peer-to-peer distribution layer, and then you can access this dependency over this Persia node or Persia network. I have a dedicated talk about this project on my YouTube channel. So if you want to know more about this open source project, check out my YouTube channel. There is this Persia video, and then I'm explaining all the details, history, and what's going on and where it's going through, and so on and so on. So, but Persia is one approach to make a secure, software supply chain security for open source projects. So, and what's part of the build structure? Repositories. What can I do, and why should I do it? So I should make sure that all dependencies during the build phase are coming through one gateway, so that you have the control, what's coming in, what's going out, what's inside, what's usable by builds. But on the other side, what is attack that's going on quite often? It's dependency confusion called, or name squatting. So it means if you have internal dependencies, and then you have Maven coordinates for this one, and this information is bleeding out of the company, then what you can do is you can create this dependency and push it under a higher version number, for example, to Maven Central. And then you are requesting internally inside your company, oh, what's the latest version? Then it's checking inside the repository, see, okay, version 1, on Maven Central, I have version 2. Then this version is loaded and delivered, and people are using it. And this is a complete disaster. This attack worked against nearly all big companies, so this is really one thing that is not so nice. And so what can you do? You're building first of all this repository structure, that everything is coming in and be delivered through one gateway inside, so that you have this possibility to make this barrier. From here, everything is outside. And then you need something like a resolver strategy. So in Artifactory, you can declare dependencies in a way that you say, okay, everything that if you're requesting this dependency, it should be just resolved inside the own infrastructure, not resolved from outside. And this will make sure that name squatting is not available for your own dependencies. And that is an ongoing attack these days. What you can do during the build phase is that you can scan all components of all technology layers during the time you're building this final Docker image or whatever. So what is the term you should search for? So the term is SAST, Static Application Security Testing. Parts of it you can do during the coding phase for sure. So scanning for dependency or vulnerabilities and dependencies inside the tech layer you're working in. But latest inside the build environment, there should be a complete SAST approach as well, the static application security testing approach, because here what you can do is you can scan the whole tech stack, scan for vulnerabilities, for malicious codes, for misconfigured configuration, all this stuff. So during the build phase, use the tools that are done by or it's done by SAST tools, is static application security testing. So checking the static semantics of this or static context of this application. So the next phase is a testing phase, and what can you do there? For example, you will have some load tests, and load tests are not only good to see how much load a system can have, but on the other side you can verify if under load the system's behavior is exactly like it's specified. So for example, sometimes systems, if they are under heavy load, they are not really making sure that all sessions are closed in the right way, and then you can misuse these sessions for other things. So make sure that during the time you have this load test, you make sure that you have an eye on all the metrics and all this behavior, and check if the behavior is exactly like it's specified, even on a heavy load, and even if it is just super slow under this load, but it's working exactly like specified and not something like this. But for this, don't check only the use case itself, check the params around it, like session management, authorization stuff, and temporal files if they're deleted, and all this stuff. During the testing phase, what can you do as well? You can start with fuzzing. Other people are calling it monkey testing. It's more or less the same approach. And what you can do with this, if you're looking with a security or with security glass on this topic, then you will identify with fuzzing. You try to make sure that different behavior is not existing inside your application. If fuzzing is not detecting some vulnerabilities, doesn't mean there is no vulnerability, but it makes sure that the vulnerabilities you're testing against is not usable inside your system. So fuzzing has a long history. It's sometimes called monkey testing. It's not exactly the same, but it's going in the same direction. You can have it a structured, unstructured, white box, gray box, black box version, and so on and so on. So there are different things, and big companies like Google and Microsoft using this very extensively against, for example, Google against Google Chrome. And if you want to know more about fuzzing itself, check out my YouTube channel. I have there a video just about fuzzing itself, so that you will get a better understanding about this. But fuzzing is something you should think about, if possible, during the testing phase. Another thing you can do is security payload testing. Security payload testing means that if your program is loading PDFs or images or whatever, that you are explicitly creating compromised images or PDFs or Word documents, whatever, and then try to feed the system with this one and see if you can use vulnerable elements or whatever you can push to bad behavior. So what the important thing here is that if you find some vulnerability, create some security payload for exactly this case, and make sure that's part of the test phase, or the security payload testing, that it's part of the testing phase, because then you can make sure that if you identify the vulnerability explicit for your environment, that this will never happen again. So that's hardened over the time. And so it's reproducible, this test. So create a library of compromised binaries, feed your system, and make sure that they can deal in the right way with this. And then what can you do as next is, for example, penetration testing. So you have to differentiate between two ways of penetration testing. So the really full-blown penetration test is something individual against your environment. It will involve a bunch of people and documentation and preparation and all this stuff. If you want to know more about really the full-blown penetration test, how you can do it, how you can organize it, what you should think about, check out my YouTube channel. I have a dedicated video exactly about how to do penetration testing or how to prepare penetration testing. But on the other side, there are a lot of common things like regular SQL injection and all this stuff. Make sure that this base set of pen test is part of your test suite, so that the basics are done just on a regular base, on a frequent base, so that you are at least, again, the basic stuff that you can automate. Okay, and if I'm in this testing phase and I have an application that I can ramp up and I can operate with it, or I can just let it run, then I can start dealing with this term DOS, Dynamic Application Security Testing. You will find under this umbrella a bunch of tools, server-side one, self-install, whatever. There's a big variety, but DOS tools that are they need something that is running already. Then you are looking from outside, so you're just looking on this application like an hacker, and then you can test this dynamic context or security aspects of this dynamic context of this application. So make sure that you're reading a little bit more about DAS, this dynamic application security testing, and then there are a bunch of tools that you can use to implement this one inside your testing phase to harm your system. So the acronym is DAST, Dynamic Application Security Testing. So next phase would be now packaging, and after this releasing. So I want to merge these two topics, packaging and releasing, here in this video, because it's more or less the same what you can do in these two different phases, and it's up to you if you want to do it during the packaging or during the releasing phase. It's more or less we have to think about if you want to create now something that I'm delivering to someone so that he can use it, what I can do to make it good to use and help to harden the usage of this one, or to increase the traceability of this one, what I'm created right now, so that later on we can identify what was going on, why what was going on, what was wrong, and so on and so on. So we're merging packaging and releasing and focusing on what I can do to make it safe if I'm delivering something to someone. Okay, and talking about traceability, what happened? So in the near past, this SolarWinds hack is more or less the point why we are talking about this executive order of cybersecurity now. And what was the content of this executive order of cybersecurity? It's more or less every software that is owned, run, used, whatever, by the US government must fulfill this must be fully traceable. So the traceability of the whole tech stack must be available. So it means we are talking about this software bills of material, so that we are able to identify this system is running. So what are the components, where they are coming from, who delivered it, and so on. And this down to the latest piece. Okay, this is for the US government, but the whole economy is so, let's say, meshed up and directed, indirected, whatever, through all the other participants, that even here in Europe we are now confronted with this requirement of creating SBOMs. Okay, executive order of cybersecurity. So now we have to create SBOMs, the software bills of material. What does it mean? So if you want to operate a binary, or if you're packaging something together and you're delivering it to someone, then you should deliver an SBOM with this, so that the other side can analyze this SBOM. An SBOM is a full list of all dependencies and transitive dependencies with a fingerprints, a version number, name, and so on and so on. With this SBOM, I can use now other tools to check for vulnerabilities, if all dependencies are fulfilling my own requirements inside my operations, and so on and so on. So this SBOM is more or less a full list of all ingredients of a deliverable. And this is maybe just a jar, but it can be a full Docker image or whatever. So an SBOM will help you to analyze what's really inside this stuff without opening it. Okay, SBOM is one thing, but we can do more. So we at JFrog, we know since a long time that an SBOM is a minimum requirement to make this traceability, but we call this long time before it's called SBOM build info, and build info is not only an SBOM. SBOM is a subset of, bugs and all this stuff. So it's more or less a full ingredients list, yes, SBOM, but during the time you're creating this binary, you have this context that will describe what is a build agent, date, time, operating system, release number, whatever, environment variables, and so on and so on. And if you're collecting all this information and you're storing this information together with a binary, you have the possibility to analyze not only the binary itself, but the context of this creation to identify security risk or changes or misbehaved configurations and all this stuff that will help you to increase security, even if this binary was built yesterday or a week ago or whatever. So this is in Artifactory. You have this under Artifactory, this submenu build info, and then you can, building on your CI environment, laptop, wherever, you can store this context information there, and out of this you can create SBOMs, but you have the whole context of creating this binary, and this will help to analyze for weak parts. Okay, next phase is the configuration phase. So you want to run it, so you're configuring it, and here the first big topic is close all ports that are not used. This is just a synonym for a lot of stuff. So, okay, if you just have one port that should be available from outside, please close all the other ports. Yes, that's one thing. But on the other side, if you're configuring all this stuff, make sure that, for example, services that are internally used inside your microservice architecture is not available from outside, and that this information is not bleeding out. Make sure that you are hiding everything and closing and shutting down and deactivating everything you are not using, and that's not necessary, because then if it is not used and if it's not necessary, you can't misuse it. So really check the configuration and deactivate everything that is not explicit required. And during the configuration phase, what should you do? You should think about who is communicating with whom, and who is allowed to speak to whom, and who is allowed to speak to me, and so on and so on. So there's one there's one important thing here at this point. Make sure that you're describing for every service who is allowed to send a request to me or send data to me, and what is allowed for me to send data through, so that this communication is not reconfigured or so dynamic that you have no clue who's requesting, who's sending through, and so on and so on. We need this later for runtime application security protection, but the strict communication metrics, if you're building up this one, make sure that no explicit or new or malicious node inside this matrix or inside this network is able to sneak around. So what is going on, try to communicate with nodes, try to get information, try to send information. So who's talking to whom is a very big topic, and make sure that this is explicitly defined. One thing I really want to mention here is Terraform. Terraform is widely used to deploy infrastructure or components. So make sure that you're following the guidelines of best practices, how to use and how to design Terraform managed environments, and make sure that you're scanning these definitions. So inside Artifactory, we have the possibility to scan now these Terraform descriptions, and make sure that you're making the usage out of this as features. So Terraform is very powerful, but it's so generic that sometimes even the simplest best practices are not that you're not following these guidelines. So make sure that explicit read about Terraform, best practices, and focusing explicit on these definitions if you're using it. Okay, now we are running, or now it's a monitoring phase in my DevOps pipeline. So the application is running now, and now I have to monitor, and there is a big term called RASP, Runtime Application Security Protection. And this means that I try to look inside this application during the time it's running, what's going on. And if you know who's communicating or what's allowed to communicate with whom and who is able to send something, receive something, and all this stuff, then you are able to analyze this and make sure that if there's a different communication metrics, for example, or different data that's sending around or whatever, then you can identify it. And this RASP is something like APM. It's an agent-based approach. It means you are installing this agent. This is adding instructions to your application, and at this point it's collecting metrics out of the running application. So RASP makes only sense in production system, makes no sense earlier, and then it's able to identify an ongoing attack. Okay, then you have two choices: report it, send an email or whatever, alert it, or just shut down the application or close the firewall or whatever. And this RASP is the last wall of defense. It's definitely not what you should use only, but it's a very good add-on if you are able to spend the money for this. And if it is allowed to use an agent-based approach inside your production, this is not always the case. So make sure that you are, aware of this agent-based approach if this is available. Then you can think about this machine learning approach to identify if there is some malicious pattern ongoing now, and then you can alert or shut down. Okay, and what else can you do? You can use, for example, the centralized logging approaches. So if you're following the secure coding practices and then you are creating in all layers the right logging messages, it makes sense to centralize these logs so that you can analyze these logs, and you have the central place where you're storing all these logs, and then you can combine the logs from different things. So with machine learning whatever approach you want to have, you can do it in nearly real time, or you can do it if something happened that you're analyzing what was going wrong. But for this you need centralized log pool so that you can merge all logs and you have a dedicated timestamp of the whole infrastructure. Otherwise logs are not really usable. So you need this identifier that is everywhere to extract sessions of the whole infrastructure. It's more or less like application performance monitoring, but now with log messages for analyzing what is going wrong or what happened in the past. Okay, this was a lot of stuff, but what the key takeaway is? The key takeaway is that a lot of stuff you can do in different stages of this DevOps pipeline, but the stage where I'm mentioned it is mostly the stage where it's most efficient and one of the early stages. So you can adopt this, the steps or these recommendations. You should learn way more about the dedicated steps because it's a huge topic, only penetration testing or whatever. These are huge topics. So if you want to learn more about this, have a look at my YouTube channel. I have a bunch of dedicated talks about these single topics. And if you have recommendations, then please, or wishes, questions, down in the comments, ask me and give me some ideas what you want to see as next. And if you want to come in contact with me, use Twitter, LinkedIn, YouTube. Please try to avoid email. It's a disaster for me, okay? So just ping me on social media and give me feedback. Let's have a discussion about all this. And so if you like this, give me a thumbs up and subscribe my channel, please. Would be a pleasure for me. But what I'm doing is next, well, it's nearly 10:15. I'm in the Swedish woods now for nearly 1 week with my son. So what I'm doing is next is I will walk to my camp, my base camp there, and will do nothing, maybe swimming a little bit in this lake, and enjoy the rest of the day. So whatever time and day you are watching this one, I hope you have a good rest of your day and you enjoyed this video. And what else can I say? Stay safe and see you